Here are solutions to homework set number 12 for ECE 111. This homework set looks at complex numbers. Now with this homework set, you can use Matlab. Matlab works with complex numbers just fine. A little bit of an overkill. When you're doing one equation, one unknown, you don't really need to use Matlab. Where Matlab really shines is next week, when we get to n equations, n unknowns with complex numbers. But it also works for one equation, one unknown. The first problem is, given a complex number in rectangular form, what is it in polar form? Well, in Matlab, just input the complex number, 3 plus 5j. The magnitude is the amplitude. The angle is the angle in radians. Again, in Matlab, everything's in radians. So 3 plus j5 is 5.8 at 1.03 radians. 7 minus j6, same trick, is 9.21 at minus 0.7 radians. Going the other way around. Again, in Matlab, everything's in radians, so in polar form, it's r e to the j theta, but theta's in radians. So if I have degrees, I've got to convert degrees to radians. So 6 at 75 degrees is, converting to radians, 1.5 plus j 5.79. 8 at minus 120 degrees is 8 e to the j minus 120 times pi over 180 minus 4 plus minus j 6.92. If I want to add complex numbers, and Matlab is just the way you type it, 3 plus 5i plus 7 minus 6i plus 2 plus 7i, and you get 12 plus 6i. Can do that with an HP calculator as well. Here you input the numbers one by one. Kind of an overkill. Go to rectangular mode, 3, enter, 5, complex. Next number, 7, enter, negative 6, complex. Those add. 2, enter, 7, complex. Can HPs use the stack? When I add the stack, and the answer is 12 plus j6. Again, not that impressive. Where HPs are really nice is in polar mode. I switch over to polar. I can say 7, enter 35. Now when I do complex, that'll do the amplitude and the angle. 8, enter 65, complex. Add those two together, it's something. 9 at negative 22 degrees. Add 19 at 24 degrees. You can also do that in Matlab. To input a complex number, I have to do 7 e to the j theta, converting to radians. So there's b1, here's b2, here's b3. Add them all up, I get a complex number. Same thing I had with Matlab. There, same thing I had in Matlab, or HP. If I want to multiply and divide complex numbers, again, Matlab has no problem with that. That's 3 plus 5i times 4 minus 6i divided by 2 minus 3i. You get a number. Matlab handles complex numbers with ease. HPs also handle complex numbers with ease. So if I do that, let's go to rectangular mode. I do 3, enter 5, complex. 4, enter negative 6, complex. Multiply, 2, enter negative 3, complex. Divide, same thing. Or if that's a little more complicated, get a Matlab, not a problem. 3 plus 5i over 2 minus 3i plus 4 minus 6i over 1 plus 3i, parentheses, whole quantity times 2 plus 4i over 6 minus 1i, and you get minus 0.2 plus j1.54. Do that on HP, same answer. So with complex numbers, Matlab works fine. One word of advice is when you get to tests in circuits 1 and circuits 2, you're not allowed to use Matlab on tests, so you need a calculator that can do these calculations. If your current calculator can't do it, you need a new calculator. If you have functions of complex numbers, surprise, surprise, the answer is complex. So with complex numbers, e to a complex number is a complex number. The log of a complex number is a complex number. Complex number raised to a complex number is a complex number. Matlab will handle this just fine. Some calculators like HPs can handle it just as well. TIs really struggle. Partial fraction is a trick that we use over and over again in electrical computer engineering. Whatever calculator you use should be able to do partial fractions with complex numbers as well. Now with the cover-up method, what I do is to find A, I cover up the term I'm looking at, analyze everything else. In Matlab, I would say that x is J4 minus J4. Then analyze what is 3 times x plus 1 times x plus 2 over x minus 4j times x plus 5. That answer is A. To find B, I'll cover up the term I'm trying to analyze. Plug in x is plus J4, analyze it, and I get 1.6 plus J, 0.2012. And finally, to get the last term with the cover-up method, cover up this term, analyze this at x equals minus 5, and you get 0.878. So everything we do with real numbers works with complex numbers as well, just to get complex numbers. The one catch is when you get to in-person tests, you need a calculator that can handle complex numbers. HP42 works great. It's a free app on your cell phone. If your calculator doesn't do it, you need a calculator that can do complex numbers. Finally, number 6, if I have complex numbers in the numerator, not a problem. To find the first term A, cover up this term, plug in x equals minus 1, you get 1.17. To find B, I cover up this term, analyze at x equals minus 3, get minus 10.4. The third term, cover up this term, analyze at x is minus 5 minus j. And in fact, these are complex numbers in the numerator, denominator, doesn't matter. Answer is a complex number. And likewise for D, cover up the last term, get a complex number. So that is homework set number 12. Everything you do with real numbers works with complex numbers, except now you're dealing, of course, with complex numbers. Matlab will handle complex numbers with no problem. Your hand calculator, no guarantee, unless it's an HP. HPs don't mind complex numbers. That's homework set number 12, or ECE 111.